there we go. Cool. And how's Phil? You okay?
Hey, I'm doing good.
Cool.
I'm excited to start printing large parts again.
Ah, that sounds like a printer has been brought back to life.
Pretty much. I'm waiting for a clip to hold the cables out of the way to finish printing.
Okay, yeah.
They should be good to go.
The little badge clip things, the retractors.
It's a good sized clip, but I found with the S5 a good way to do it is it's put a clip like in the middle.
Oh yeah.
On the back side, you put it in, and just hold it there, and then it keeps the one side up, and then there's usually enough tension to keep the other side up when you go all the way over, so it keeps it out of the way of the build.
And now we've become very proficient at managing printers, don't we? So to speak, or not managing them. Hey, Steve.
How you doing?
Good. How are you?
Yeah, at work, as you can probably tell.
I can see. Yeah. Are you in this? Is the escape room work?
Yeah, that's one of the rooms behind me. I'm using the works computer.
Oh, right. Okay. How's it going?
Yeah, today's not been too bad. We've had a reasonable weekend. We've had 3 groups through here today, which is all right for Sunday. I'd prefer it was 3 or 4 times as many, but beggars can't be choosers.
Yeah, exactly. It's a funny old time at the moment, isn't it?
Yeah. Over here, we're not doing too bad. You know, we haven't locked down, so that's okay. So yeah, we're still open for business, so that's good.
Yeah, we haven't not locked down. we're pretty much been like this for some time. So anyway,
I'm going to probably be on mute and maybe with my screen off. But if there's anything I can interject with at an appropriate time, I'll come off mute.
Yeah, no problem. See how it potters along. Oh, there's Trevor. Hi, Trevor.
Hello.
Hey, how are you?
Well, not too bad, yourselves?
Yeah, good. Right, we'll make a start. We're recording anyway, so if anyone joins a little bit late, they can always play catch up. And I've managed to remember to hit the record button this week, which is an amazing feat. Normally, it's somebody who reminds me. This time, we've kind of got it in place. So. I suppose like last time, what we said we'd cover off this time is batteries, amps, voltages, watts, and how you calculate your battery size and potentially how you calculate fuses, etc. Whoops, I'm just letting people in at the moment. Because I think what we've covered up to now is all pretty much the real sort of basics. So we'll start to get a little bit more advanced into some of the electric theory that sits behind it. And I know we've probably got a few people on here that know this already, but let's go back to the basics. All right, let me just share my screen and find what I was sharing. There we go. Just do a little bit of this first, just talk through. This is just really so we're all on the kind of same page about electrical, really basics. So there's a couple of things that are elements of electric, of which the 4 ones are voltage, resistance, current, and power. And if you remember this way back from school, probably, where most people learn this, what you tend to think of it is you think of it as water. So your capacity is your water tank. Your voltage is the water pressure that's pushing the water down the pipe, and that's measured in volts. The resistance is the size of the pipe, so the narrower the pipe, the less water can flow through it, and the wider the pipe, the more water can flow through it. And we use that when we're putting fuses in circuits, because what we're doing is creating a narrow pipe specifically that protects the rest of the circuit, so that if it goes beyond that threshold, the fuse will blow. So resistance is that width of the pipe, and we measure that in ohms. And current is how much water comes out of the pipe. So that's in amps or amperes. And then, as I said, what the fuse does is literally a device that shuts the power off to electric circuit when there's too much electric that flows through it. The confusing thing with this is what we've got on our builds is lots of different components. So we've kind of got we've got all of the motors and electric circuits and sound cards and things like that. Each of those draw a certain amount of current. So to be able to put correct fuses in it and understand how long your batteries last, you've got to be able to either calculate that, which is very difficult to do, or measure it so that you get a greater idea. And I guess what most people do is they kind of get the basics, and then what they do is take a little bit of a educated guess as to what's the best size battery. And failing that, what you do is put the biggest battery in that you can do, and so that you get the maximum amount of running time. So the other thing that we'll cover off is battery capacity and size, because this is something that we got asked last time, and it comes up quite a lot, which is how big of a battery do I need to run, my build or my droid for a day at a convention or whatever. And all batteries tend to have these milliamp hours, which is an indication of how much current is actually stored in that battery, and you can run it until it's empty. Now the way, and this is measured in, as you can see there, so the example that's given is a 1300 milliamp hour LiPo, and what that means is it can run 1300 milliamps an hour. So if you draw 1.3 amps, what you would get is an hour running out of that battery. If you draw 2.6, so if you draw double, you get 30 minutes. And likewise, if you draw 650 milliamps, which is very little, you get 2 hours out of that battery. So the battery capacity is fairly easy to calculate. The difficulty is actually, again, knowing your circuit and knowing what it actually draws. And the critical thing to understand in that is the actual ampage. So how much amp is running through your circuits and your motors. I don't know for anybody who's tried measuring this, but when you do measure the ampage that goes through things like motors, etc., I'm always surprised at how little is actually drawn through there compared to what I've been expected to. So what I'll do is, that's a little bit of the theory, but what I'll do is just kind of show you how you can actually measure that now, and hopefully I'll do that without blowing myself up. And if I do blow myself up, it'll be something to remember and celebrate at the next Drinks and Droids.
Electro Boom has entered the room.
Exactly. Now, how do I stop bloody sharing? Stop sharing there.
Are recording, right?
We are recording, yes. Yes, I managed to do that, which is great. Whoa, hang on, I've got Marine. Let me just let Marine in. There we go. I'm managing the waiting room. Right, while Marine's joining, I'll just switch over the camera. So this is where I'll hopefully blow myself or not. Hey, can you see that and can you hear me okay?
The sound's gone a bit quiet, Michael.
The sound's gone quiet. I've switched over to the... let me flick it back then.
We can see fine, but the audio has gone very muffled and quiet.
Is that any better?
Yep.
Yeah, okay. I switched over to the one that was actually in the camera that I was talking to, but obviously it's better through this one. Right, what I've got is I've got an old, well, I've got a failed print of one of the mouse droids that I've used to create a test rig. So what I've got here is I've got a small motor, which is something that's going to draw current. Obviously, I've got the power cables coming off that, and all that runs is straight through an RC circuit to a small electronic speed controller, and runs off a receiver. So all I've set up here really is a motor and a controller, just so I can control the speed. What I have done though is on the actual live cable that's going into that, I just split it off so that I can actually measure between, I can put a break in that circuit. So if you were to put a fuse on that, that's typically where you put the fuses between those two cables. So all I've done is put two little nuts. At the moment, they're just shorted across with two connectors. So it's one circuit. So all it is an electronic speed controller, a motor, and a receiver. Does that make sense up to now?
Yep.
I've got a battery. So it's a 5,200 milliamp hours. So that means that will run for 5 amps for a whole hour, or will run 1 amp for 5 hours, which is kind of what we looked at before. And this is an 11.1 volt LiPo. Again, the voltage is quite deceiving, to be honest, on LiPos, because that tends to be your minimum voltage that it'll actually run. The voltage is a little bit higher than that normally. So let me just connect this up. So I'll plug that battery in, like that. There we go. I don't know if you can see there, but the little receiver's flashing. And I'll fire the remote control up. There we go. Right. So all I've done is I've put that motor, which you can see here, it's on this stick. So if I can actually leave it running, which is quite handy. So we can kind of start to look at some things. So the first thing we'll look at is we'll look at voltages. Now, we have covered off these a little bit, but multimeters are great little devices if you want to kind of play around with this sort of stuff. So the important thing with multimeters is you get the cables in the right side, and you get the dial set correctly. So at the moment I've got one cable in common and the other one's in voltage because I'm measuring voltage or resistance. They're all the same on multimeters. I'm going to pop it onto this side, which is DC, and I'm just going to measure 200 volts DC. So hopefully, if I pop that there, you can see. And what I'm going to do now is I'm going to measure the voltage that's going across this motor, the two terminals of the motor. So as you can see, there's no voltage there at the moment because the motor's not spinning. If I just alter the stick a little bit, so hopefully you can hear the motor running there a little bit. And what we can see there is we're getting 12.2 volts across that motor. If I reverse the motor and do the same, I'm now getting minus 12.1 volts. So what I'm doing there is measuring across the two terminals of the motor. And if I slow that down a little bit, and I measure across the two, not that much though, slow that down a bit, measure across the two terminals, I'm getting, you can see 9.5 volts. So as all the speed controller does is it reduces the voltage that's going across those terminals, so it slows the motor down, so 6.5 volts. So that makes sense. So what I'm measuring there is I'm measuring the voltage that's coming out of that speed controller by the RC. So that's your voltage. Now what I'm going to do now is I'm going to measure ampage. To measure ampage, rather than measuring across the terminals, what you've actually got to do is put the meter in between the live or in between a live cable. So the meter actually makes the circuit, and I'll show you what I mean by that. So, and this is the reason that you have on voltmeters is you'll have one side that has an ampage on it, and you'll have a common, and then you'll have another side that has voltage and some small ampage on it. Obviously, what we're going to do here is we're going to put take the live cable out of that's coming out of that speed controller. We're going to put the live cable into the common. The other side of the live cable is going to go back out, and then it's going to go through to the motor. So if where you would normally put a fuse in the middle of that cable, the actual meter is going to sit there. And the reason, and if you look on many meters like this one's actually, the meter itself has got fuses in for that reason. Now the reason that you've got to be really careful with these is when you're measuring voltage, don't switch it over to ampage, because what you're actually doing is you're creating almost a short because you're making the circuit. So you've got to be really careful with that. So what I'm going to do now is these two connectors that I've got on here. Just see if I can show you what I've done now. So what I've got now is I've got on each of where that circuit originally was shorted across between those two, I've now put two cables on. So if I connected these two together, the motor was running. What I'm going to do is I'm going to put one of these cables into the common, and I'm going to put the other one into the 10 amps. So what that's done now is it's put the meter in the middle of the circuit, and I'm going to put the actual meter now on 10 amps. So this is how I'm measuring current. So the motor I've got at the moment is Pololu 37 diameter motor. 12. It's a 12 amp motor. It's rated at rest. Sorry, when you've got no load at all, it's rated at about 0.2 amps. And this is a challenge, because when you're trying to work out how long your batteries will last on various builds and whatnot, it depends on how much load you're actually putting it under. Because if you can imagine, it's a bit like saying how much petrol or how many miles will I get to a tank on my car. It depends how fast you drive it. It depends whether you're driving up hills or not. And it's exactly the same when you're trying to calculate how much you'll get out of a battery. So I've got the multimeter in place now. The multimeter, what is actually making the circuit, so one of those little fuse blocks is going all the way through to the common, and then the other one is going back out, and that's connecting to the motor, if that makes sense. So now what happens is when I start to increase the speed of the motor, what I'm seeing there is the ampage that's being drawn. So if I speed that up, so that's just in idle, i.e. there's no load on that at about 12 volts, because I've measured the voltage. It's actually drawing 0.14 amp. Now if that's drawing 1.14 amp, and this capacity of this battery is 5,200 milliamps, it means that I'm going to get a hell of a lot of time out of that battery. Now, if we simulate load, so what I'm going to try and do now is I'm going to grab the battery and try and slow it down. What you can see is the ampage going up. So now instead of it drawing 0.13 amp, I'm getting up to about half an amp. So and these motors actually have a stall. The stall ampage on these motors is about 5 amps. So it shows you that actually, I'll grab something a little bit stronger here to try and stop it. Got a pair of pliers. Obviously, I can't bloody grab it now. I'll see if I can get it to noise a bit more low, but there we go. You can see I'm pulling about 1.5 amps, 2 amps. See if we can blow something up. So this, there we go. So the stall, when it says a stall, the stall current on them is about 5 amps. I had to near as damn it stop it to get it up to 2 amps. So they're actually talking about completely stopping that motor to get anywhere near that 5. And obviously what you'll start doing is actually probably burning the bushings out. But you can see how that's ramping up. Now that's what I'm saying, is when you're trying to calculate your battery capacity, it depends on the load and what's actually going through that. So in reality, calculating these things is probably not as good as actually measuring them. Now what you can get, and I think you've probably seen all the shiny lights that you get on the back of under the back panel of droids and whatnot, is you can get devices that will sit in there and actually give you a running display of what your voltage and what your ampage and current is of what's running through there, similar to what you're getting on here. kind of little LED panels. But it's quite handy that for working out those kind of things. Right. Let me just slow that down. Stop that for a minute. Does that all make sense?
Yeah.
So,
Hey, Michael.
Yep.
I have a question for you. So, when you have batteries and servos and all kind of components running, and you want to start adding fuses, how do you determine the load of all the components so you can fuse everything correctly?
That's a great question. If you just bear with me, let me just fire back to that one there. Let's have a look. So, what each of the components you've got, you can actually calculate. You can calculate what amperage would go through that. So you could calculate that per component. Now the problem you've got is, as we showed there, is that when you start to put things under load, the amperage will go up. So you'll start to see a load amp. But if we look at the E90 Razor motors, which is what we've got in the in most of the kind of printed builds that I've done so far, those motors are 100-watt motors, and most of the motors that you see, that the wattage will be documented, so you'll be able to see what wattage it is. Those 100-watt motors are running at 12 volts, and if ampage, so to calculate the ampage is your wattage divided by your voltage. It's as simple as that. So if you just take that one particular motor and you say, right, what fuse should I put on there? What that's saying is that it'll run typically at 8.33 amps. Mm-hmm. Now, the problem you've got is when you first start off a motor, because inside there's kind of bushings and there's electrical sparks and all sorts of things that kick out when it first kicks in and first starts to run. Is what you'll do is you'll see a bit of a spike before it'll actually settle down again. Yeah. So again, this is really rule of thumb, but rule of thumb is that watts divided by voltage, which is your 8.3, and then add another quarter on there. So, typically you might want to fuse those at 10 or 12 amps, and that's per motor. So if you've got two motors running either side, you then look at getting closer to 20 and 25 amps.
Okay, so that's how you know what, if you just wanted to just fuse just the motors, just have it a fuse just for those, you would just basically get a 30 amp fuse just to be safe for those two motors.
Yeah, you would. Now, and I wait for Steve to jump in, but on the Sabertooth 32s, they don't recommend that you fuse them at all.
Okay.
Which I can never remember. What's the reason, Steve?
I'm not entirely sure that they publish a reason, but I would think it's because of the actual onboard protection built into the Sabertooths themselves. I think they are effectively fused, but electronically. So rather than actually popping a fuse and then you having to fumble around and find a new one, it will you can just soft reset it.
Yeah.
The other reason is fuses are resistors.
That's true.
And so you have a resistor in line with it, and so with the Sabertooths, they have a regeneration circuit. So they're trying to dump power back to the batteries. And basically with that fuse in line, you have a resistance to go back there, and it probably screws up with their stability control system for that is part of the reason why. And also you get a voltage drop across the fuse. So when you pull power instantaneously, you're going to get a voltage drop, and that can mess with the control systems as well.
Yeah, it's certainly not a requirement that if you are running a Sabertooth speed controller that it is fused. In the UK, as I'm sure most of you know, we have a tier of clearance, tier 1 and tier 2 droids for sort of film work or for for Comic-Con type attendance. It's just an internal club thing we do, and I have checked whether or not if you're running a Sabertooth that it should be fused, and the answer is no, it does not need to be fused. But if you've got other components in there, like an amplifier, for example, or I don't know, something that moves arms around or whatever else, then yeah, fusing them is a very good idea. And of course, most little sort of cheap fuse blocks that you can buy off eBay have got multiple connectors, so you can have a 2 amp fuse running one particular thing and a 5 amp fuse running something else, and you just have to wire them individually from your main bus supply.
Okay,
You have to remember what fuses are for, right? Like fuses are there to protect the wiring and the battery. They're not there to protect your downstream equipment. So they need to be sized appropriately to protect that stuff, not necessarily what you're drawing. Everything needs to be sized appropriately for that.
Yeah, so that was my question. Because see, I have the basic idea of it, but I need to know, besides the saber tooth, when I'm fusing everything else, how to calculate that. But Steve answered my question about what to fuse. And thanks too, Trevor. Thanks, guys.
I think Trevor's point's really important. You can calculate what draw your components are pulling, but as Trevor said, what you're trying to do is protect some of the big things. I mean, personally, and again, there is a science to this, but for what we do, I think what you're trying to do is you're trying to protect yourself from fires, explosions, or death. It's not much more than that. And if you're running, if I'm running a UBEC, which converts 12 volts to 5 volts, and it's an 8 amp UBEC, I might just fuse it at the 8 amps. In other words, what I'm doing is, as Trevor said, I'm protecting the battery. In this case, the UBEC's what's giving me the current, so I'll just fuse it at that. I'm not getting too hung up on kind of what's happening further downstream, as in your amplifiers or whatever else you've got running on there. If the little kind of inline amp displays does give you a good feel. Now, for me, they're more important probably to understand the battery capacity than they are around fusing. So what you do is you're running it. If you're running build around and you kind of you're drawing 2-3 amps because it's idling, it's not a particularly heavy one, then you know that you can get away with slightly less capacity batteries. So you can monitor that and then judge your battery capacity accordingly.
It can also give you an overall idea if your system is running as expected. So if you think that you should be drawing 2 amps and you measure that you're actually drawing 5 amps, then you might have a fault somewhere, something that's not quite right. They definitely handy things.
And that's why it's useful to get grab a meter and just start to play around and get a basic understanding of your voltage, your amperage, what's going through there, and get comfortably measuring it. We had a chap that messaged me the other week because he had one side of his build where the motor just was running much slower than the other side. Now, I tried to talk through different ways of isolating it by swapping components out, but had it been me, I'd wanted to get a meter out and to see if one of the motors was drawing more current than the other motor, which probably means that there's something binding, or you can then start to use it to fault find.
Yep. Thanks.
Oh, cool. Any other kind of questions while we're talking around the fuses or the or battery capacity?
Yeah, I got it just to clarify. So I got the Padawan 360, and if I just look at the battery, saber tooth, and the motors, so I wouldn't put any fuse in there anywhere, or I would put it between the battery and the saber tooth, but not saber tooth and motors.
So would you put the fuse between the saber tooth and the battery power?
Yeah, or do I not need a fuse at all because it's the saber tooth?
I don't think you need a fuse at all. Steve's nodding and putting his thumbs up. I think the recommendation from Dimension Engineering is that you do not fuse the saber tooth in any way.
Anywhere, okay. Okay, and then the regenerative feature of the Sabertooth. If I want to just push it around in my living room just to move it without power, do I need an on-off switch between the motor and the Sabertooth to turn off both motors so it's not, I heard it can damage the Sabertooth?
What I would recommend you do, rather than have a switch, unless that switch is very heavy duty, because bearing in mind, you know, you can push 32 amps out of a single channel of that thing. So you should have a fairly heavy duty switch if you're going to do that, which is fine. But what I personally do on mine is I actually disconnect the motors altogether. So my motors go to my Sabertooth via a pair of XT60 connectors, which is rated to 60 amps each. And I simply unplug the, if I'm going to push it any distance, then I simply unplug the motors.
Okay, but a couple of feet, I don't have to do that if I just want to.
If I'm just literally pushing mine around my living room or getting it onto its trolley or something like that, then I typically wouldn't bother. I've never had a problem. The issue with the regenerative braking, where it's a little confusing if you read the manual and you don't fully understand what it's actually saying. It mentions about power supplies. So if you're using what we call a bench power supply, you know, something that you plug into your main supply and it gives you 12 volts out, then pushing voltage back into that is a very quick way of terminating its existence. Batteries, not so much, but if your battery is not connected, then that voltage effectively that you're regenerating back through the Sabertooth has got nowhere to go. If you isolate your battery altogether and you push it around, then yeah, I wouldn't do that long term. I'm not sure quite how protected the Sabertooth is. I know you can put shunt resistors and things in, but we're sort of beyond the scope of this particular chat if we start talking about that sort of stuff.
Okay, thanks.
I think the general rule of thumb is have a physical disconnection for your motors if you're going to shove it a very, very long distance or you know, sort of big moves, but just shifting it a couple of foot. And again, you can, you know, speed will affect that. So if it goes slowly, you're not going to generate much voltage anyway. You know, if you suddenly try and shove it along at about 12, 15 mile an hour, then you might start to generate more voltage than what the system will take.
Okay, thanks.
Cool, thanks. Any other questions we want to ask?
Yeah, I got one.
Yeah.
So with the milliamp hours or amp hours,
yeah,
how is that affected if you connect two batteries in series?
That's a good question. So if you connect batteries in series, that's taking your plus from one battery into your negative to your other. What you'll do is increase the voltage, but still have the same running power. So what you'll do is if you connect two 12-volt batteries in series, you'll end up with the same milliamp hours, but what you'll have is a 24-volt battery. If you connect it in parallel, so you connect the two reds together and the two blacks together, what you'll have is double the capacity, but the same voltage.
The best analogy I always use if someone asks me that question is think about it as if you're jump starting your car. So if you're jump starting your car, if your battery's flat, then you connect black to black and red to red from your donor battery, your spare battery, and it gives you a capacity boost. It's not increasing the voltage because you don't want to do that. It's increasing your capacity. And also, Michael, if I can just sort of, sorry for jumping on it, but just to clarify something else as well, where if you're talking about doubling your voltage, if you've got two 12-volt batteries and you go red to black, do bear in mind that you should, as close as possible, keep the same milliamp hours on each battery. So don't put a 2,000 milliamp battery and connect it to a 60,000 milliamp battery, because that's a one-way ticket to blowing up your 2,000 milliamp battery. So if you've got a pair of, for example, in my Droid, I run a pair of 17 amp hour 12-volt lead acid sealed batteries, which I run in parallel. So I've still got 12 volts, but I've got a total of 34 amp hours, which will last me, you know, a week of running around. It's, you know, it doesn't draw that much. If I wanted to speed boost my system, first of all, I need to make sure that everything is capable that's connected downstream of running at 24 volts, and then I could put them in series as opposed to parallel. But obviously, bear that in mind with your own particular builds. If you run in series, then you are doubling the voltage, or whatever voltage you're running. So if you've got an amplifier that's only rated to 12 volts and you suddenly chuck 24 volts into it, the blue smoke's going to escape, and no matter how much you wave your arms, it's not going to go back in. Ask Rick.
Yeah. No, good question. Any other ones? No, we're all experts now, which is
Getting there.
getting there. Yeah, and I think, as I said, the best thing to, from my perspective, is to grab a meter and just play around with circuits. The one that one that I just went through there with the motor and the battery is something I just threw together today so I could share with you guys. But those kind of things are quite useful. You got a meter there, Steve, have you?
I am never, wherever I'm sat, even at work, I am never more than an arm's reach away from a good meter.
Okay, I have a question, and this is a completely new. I've had multimeters. Sorry. What do all the things on the multimeter mean? Because there's like it's
a cracking.
I'm not sure like which side means what, which side means the other thing. That type of stuff.
So yeah, just really good question. Let me just see if I can flick the video over. Let's have a video. Yeah. So what you're talking about, and is I think if I can get damn thing in focus, is all of these symbols around here. Is that what you mean? Oh.
Yes, that's exactly what I mean.
Yeah. So so what you've got is you've got some different symbols that are on there. So there's a little this section here. I'll just talk around it. This section here is voltage.
Mm-hmm.
Just not very. I don't know why it's not focusing properly. It's not really quite good, this camera. I'm just trying. There we go. That's a bit better. Yeah. So what you've got here is you've got voltage. So it's got a little V which indicates its voltage, and then there's a there's kind of a straight line. Looking. Yeah. So this says this voltage, and there's a little straight line. So that's voltage in DC. Do you know the difference between DC, which is direct current, and alternating current? So direct current is what you would get out of a battery. Alternating current is typically what you get out of plug sockets or mains electricity. And the difference is that with DC, with direct current, you've got a live, which is 5 volts, and you've got a 0, which is obviously ground or whatever. With AC, you've got a ground, and then the voltage actually goes up and down really, really quickly. So you actually need to measure the two differently on a multimeter. So this side here with the little voltage with the straight lines is for measuring voltage. And you'll see there's all different numbers in there, which is going from 600 volts, 200 volts, 20 volts, and then 2000 millivolts to 200 millivolts. And what those are is they are for depending on what you're actually measuring. So if I was measuring mains voltage in the UK, which is 240 volts, I'd tend to go into AC, which is this side, so 600 and a little V. And you can tell it's AC because it's got like a wibbly line on. So I'd flick it onto that, onto AC, 600 volts, because I'd always choose a number that's higher than the voltage that I'm trying to measure. And that's where I'd start to be able to measure my mains voltage. For most of what we do, which is DC, I'd do this side. So if I'm measuring 24 volts, I'd flick it to 200, always the one above what you're actually measuring. If I'm measuring 12 volts, I might flick it to 20. That's again higher than what that's your maximum that it would actually measure. So they're your two common ones, which is your two voltages. Then as you come round, you've got this little symbol, which is, I don't know if you can kind of see it. It's ohms. It's resistance. Is it an Amiga symbol? Is it like a Greek symbol? Is it Amiga, Steve? Yeah.
Yeah, Amiga. Yeah.
Yeah. So, and what that is that's measuring resistance. So if you've got a 1 kilo ohm resistor that you want to measure, again, similar thing. You can pop it onto the 2,000 or 2 kilo ohms, 20 kilo ohms, and you can go down and down and down. And what you do is you put that either side of the resistor and it'll measure the resistance. So you've got DC voltage, AC voltage, resistance, and then you come to everybody's favorite, which is a little diode tester stroke continuity. That's what most people know, because that's the, I touch my two ends of my meter together and it makes a beep noise test, which is great to make sure that you've got continuity as you go through. And then this one particular one's got some battery checkers, so a 9 volt and a 1.5 volt just for standard batteries. And then when you move around onto this side, this is your current, which we've just been measuring. So you've got your 10 amp current there, which is again for your higher ampage, and then you can start to go into your milliampage ones on these ones here. Now, what you've got at the bottom is you've got a special connector for the red that's specifically for the 10 amp, because what I'm saying is that the meter actually sits in the middle of the circuit and the entire current goes through the meter. So you've got a dedicated one if you're doing 10 amp measurements, but all the rest will typically go into these two. The common one in the middle is just the common reference connection, and then the one on this side here you'd use to measure voltage, resistance, and milliamps.
One thing to note with those is those amp readers are fused. So the small side is usually fused to a lower level, 450 milliamps or something. It should say on your meter what it's fused at.
Yeah.
And then you have the 10 amp, which is fused at 10 amps. And depending on your meter, those fuses can actually be very expensive. So
this is 200 milliamp on this side.
Right.
Trevor.
So that one's 200. So if you go over 200, then you could pop that fuse, and then you'll sit there wondering, why am I not measuring any current anymore?
Which I did today, just before we started this, Trevor.
Ha.
So I was measuring this motor in milliamps, and then I was stalling it, and obviously I flipped above the 200. So I popped the fuse on this side for the milliamps. Hence why I did the testing on the 10 amps today. I'm hoping what on the older meters, I've not looked at this one, to not had a proper nosy that you used to be able to just take this back off, and there was a couple of little fuses that you could pop out and swap. Would be behind the battery, but it may not be the case. We'll see later on. Okay, Anne. Anna.
Hi, Michael.
Hi.
Oh, you're back.
Fuse.
On some of those meters, like the fluke meters and such, the fuses are protected fuse, so they're a non-flash, non-fire fuse.
Okay.
So they can be very expensive, like $50 a fuse. So you don't want to pop those.
Yeah, if you could have let me know probably about 3-4 hours ago, that'd been really hard. So, yeah, no.
I think on these cheap fuses, on these cheap meters, they're not the same, but on the flukes, they're very special and very expensive. You feel really dumb when you do it.
Yeah, thank you. Appreciate that.
We've all done it, so it's not an uncommon thing to do.
Do only tend to do it once though, Trevor, I find.
Well, I would have thought so, but apparently I've gone through a few. The meters at work all don't measure 450 milliamps anymore.
Bizarre.
Yeah, I'll take the back off this. This is prevent fire, install fuses with amp rating shown, 200 milliamp. I think these are just standard fuses on the back of these, to be honest. I think this will just be a...
They probably are just the glass
Yeah.
I forget the designation, H
I
or
can-
something.
I can see you're all trying to cheer me up. Anyway, thank you. Appreciate that. It'll be fine. I don't measure amperage very often anyway, and the voltage and all the rest of the measurements still work on that.
The continuity feature is a great way of actually checking if fuses have blown, just to sort of point that out for people who may not be familiar. So if your meter has got a continuity, well, every meter's got a continuity feature, it's a very, very simple way of checking if a fuse has actually blown. That's probably forms 90% of my sort of standard checks I do here at work, is just checking for blown fuses.
You just pull it out of the circuit first, obviously.
Yeah, absolutely.
Sorry, yeah, well, very well reminded, Trevor, thank you.
The other thing you can get, I mean, I tend to get the bag of different connectors for the meters. On some of the more expensive ones, you get different ones, but they're there's nothing worse than the standard ones that you get with the two little pins, just waving them around tiny little circuits. And because you're in a rush, which I always am, assuming that you can quickly measure it and it'll be fine, and then you end up shorting something out and again creating blue smoke, which doesn't help exactly. So yeah, so it's worth kind of looking around on the meters and some of the different connectors and whatnot that's available.
Hey guys, how good is this? I have one. I've had this for a couple of years. It has a resettable fuse. I guess is that okay? Yes.
Yeah, that's fine. The resettable fuses are the only issue with a resettable fuse is they will pop at different points depending on temperature, and that's how they pop. They heat up and then they open circuit, and then they cool off. They'll go back again. So it's unknown a little bit of what they're going to pop at. But for a meter, they're great because they'll pop when it's too high to damage the meter, and then they'll come back when you realize what you did.
Ah, okay.
Nice.
I've never popped it, and I don't plan on popping it, but I looked at it and I never just thought about it, so I just thought it was good too.
Either that, or there'll be a button inside, and it'll work like a circuit breaker, and you got to push the button to reset the fuse.
Okay.
Thanks.
Cool.
Thank you. Okay, well, I think we've pretty much covered everything that we're going to cover, unless anybody's got any other questions. No?
Yeah, one last question. You put the fuse on the positive side, is that right? Coming from the battery, let's say?
Yes. Yeah, you typically fuse the live cable, obviously, not the return, which is your negative. So that's the red wire.
Yeah, the reasoning behind that is that depending on your circuitry, it may be able to find an alternative route back to ground, like through another component.
Yeah. A lot of circuits will have common ground, so all of the black wires will all be connected together, whereas your power wires will be running to specifics.
It's very much, and it's also fuses are resistors, so you don't want your resistance in your ground path, typically.
Okay.
Yeah. Cool. Are you building that board, Trevor? How are we doing with it?
Yeah, we got a couple of those done.
Yeah, okay. Yeah,
I haven't tested them, but they're built.
Yeah,
They're pretty easy.
they are. They work really well. The one thing that just a little bit digressing, but we'll quickly talk about it. The one thing I've noticed is you do get there was some differences on nanos. So with the DF player, they worked absolutely fine, no issue whatsoever on two of my builds. I did the third one, and I couldn't get the nano to start to talk to the DF player at all. And then when I triggered the DF player with just by shorting the pins out, which you can do to trigger the sound, there's a lot of background noise, as sounded like power noise. When I swapped the nano back to the other one, it worked fine. So it seemed to be nano related. Now, I know there's been a few things on bulletin boards about putting a 1K resistor on the TX and the RX line to try and reduce the power, to reduce that noise. I popped a 1K resistor on the RX, I think it was, because we've got the jumper, haven't we, anyway? So you can make a jumper with 1K. But what I have to probably do is cut the track on the other one to.
It's the TX line that's probably going to be the one that's going to cause the noise.
Yeah.
It'll be the TX one, in which case you're going to have to cut that trace, which is just, you can see it. Well, you can't see it here, but it's right here. It runs beside the jumper.
Yeah.
So you'd have to cut that trace with a knife and then solder your 1K between.
Yeah.
I haven't fired those up because you haven't sent me the code.
Okay.
And that was a subtle hint, right?
Yeah, no problem. You will get it immediately after this.
And the TX line is what's coming from the Nano to the DF player. So if anything's going to reduce the noise, it would be the TX side. Yeah. I have obviously one of the cheap ones. These are the ones I used on the BD1 boards, and they work there fine. But these are $2 nanos or $3 nanos. So I guess we can't expect too much of them.
No. Well, what I'll do is I'll pop your code across to try them, and then I'll just see how easy it is on the to trim that line.
Something else, just to may or may not help. Actually, I did a project where I used that sort of setup, a Nano and a DF player. Nothing to do with droids. It was something for another escape room. And I got awful trouble with extra line noise. And it turned out that the DF player ran better at 3.3 volts instead of 5. So I'm not sure what your boards run at, Trevor, if they run at 3.3 or 5.
These are running at 5. So that could very well be. I have seen reports that some of the DF players don't like the 5, and they are definitely noisy at 5.
Yeah. So I'd ran mine instead at 3.3, and it was perfect.
Yeah.
Okay.
So that would require us to. So we could do that, Michael, if we needed to make it better. You just have to change the regulator to a lower voltage one.
Okay. So if we put a 3.
Or is there a way of tapping the 3.3 line that comes out of the Nano?
Not enough power there
to run the DF player.
Yeah.
Nah, probably not.
Not with the amplifier. Not with the 3-watt amplifier on there, right?
Okay. Yeah, fair enough.
That 3.3 on the Nano, the 3.3 volt output is actually the internal regulator of the FTDI chip. So it can't supply much at all. It can be a reference line, but it can't supply any power.
Okay.
So literally, is that all that would need changing, Trevor? Just that regulator?
Yeah, because the Nanos will run down to 3.3 as well. So you could put a regulator in that would drop it to say 3.3 or 4 or something to give ourselves a little bit of headroom. And then that would power the DF player and the Nano and the Bluetooth as well at that lower voltage. So everybody would be happy there. We just
you've got voltage dividers on there, haven't you?
Yeah, we have the voltage dividers for so you'd have to probably, if you're running lower voltage, you would have to take those out, but potentially. But yeah, if the DF player wants a lower voltage, then that's how you would need to do that.
Well, you could keep in theory, keep the same board, drop the regulator, and then just wire the resistor slightly different.
Yep, absolutely. The downfall there is if you start going too low, you could end up not being able to drive your servos to the right level because they're going to be running at a lower voltage. The signal will be running a lower voltage than.
Yeah. Okay. Well,
eventually there's going to be a crossover point where stuff's going to stop working, but it might clean up the DF player.
Well, I'll send you the code across. As I said, the ones I've got running are working without an issue, really. I don't know whether I'm looking for the mouse droid, but I've got it somewhere, kicking around. God knows. Yeah, but it's
mine are. I have to say, mine are much prettier at blue than yours.
The much what? Sorry.
Mine are much prettier looking with being blue than your green ones.
Oh, you see, I like green. I'm not a fan of the blue ones. They're not pretty. I don't believe that for a minute. But yeah, I'll drop you the code over afterwards anyway, Trevor, and you can have a little play with it and see what it's like on those nanos that you've got.
Sure.
all the rest of it works. All the Bluetooth and the controls and everything works without an issue. It's just we might have to just play around a little bit with that DF player.
So what is the goal of this product that Trevor's working on? Sounds.
It's a little Bluetooth board for the for any of the small droids.
Oh, okay.
But it's got I'm trying to find where I put the. I've got a couple of them built somewhere. In there.
So while he's looking for it, I can slide. Basically, what we've done is we've taken the Nano and then we wired it to a DF player and then a little Bluetooth module which goes right here, and then brought out the servo connections and some other inputs, and put a little regulator on here so you can run your servos at say 6 volts, but still run the Nano and everything else at 5. So just a little bit of little simple controller there allows you to do Bluetooth to control your servos and music triggers.
I got it. Okay, I see what you're saying.
These DF players are ridiculously cheap. Like Banggood has them on right now. I don't know if they're any good, but you can buy 5 of them for $7.
Yeah, I'm looking at one now for like.
Hello.
Yeah, pretty cheap.
Okay,
are those ready, Trevor? Are those ready for a run or something? Those.
So Michael has the boards on his site.
Okay.
You can buy the bare boards. There's been no talk of doing an assembled run like we did with the BD1 boards. I don't think that's necessary. I think you can buy the parts, and it's a good exercise to solder them together. Said I sort of built a couple here while we were talking today, so they're not that hard.
Yeah, so this is that camera's legs falling off now. Yeah, so this is a little mouse droid. So this has got one in, which you can hear there. Trevor is crystal clear, really.
Yeah.
There's no. I'm just propping the bloody camera up. Yeah, so. Let's set those off. What you've got then is you've got a little speed controller, a Nano. That's the Nano I've got on this one. A board, and then underneath the board is a little Bluetooth connection. So there's turn it off. There's a little app which is called Dabble. So all you do is once you fire it up, it comes up as DS Tech. Once you're connected to that, then you've got sort of full Bluetooth control with a little keyboard. So that does steering and speed control. And then as Trevor said, there's a bunch of connectors there, so you can put servos and all that kind of stuff connected to them.
Okay. Did you say that you could also control that with a RC?
Yes.
Not Bluetooth?
Yeah. Yeah, absolutely. You can. All you really do is you just need a small speed controller for the main motor, and then the other steering is just done straight out of the receiver.
In theory, you could use the same board with RC and just plug your receiver inputs into here, so you could still get the sound, and you could trigger it off of your RC remote as well.
Yeah, okay, that's where I was going. I have a full-size mouse droid that I built, a 3-channel remote control, and right now I have a really cumbersome sound system in there, basically an iPod with into an acre amp and speaker, and it just randomly plays tracks. But I'm wondering if I could use that board and the 3rd channel on my remote to trigger the sounds.
I think that probably is possible. with some software.
Cool. Thank you.
Yeah, it's pretty flexible, that board, but we're just playing with it at the moment. We'll see how it comes out, and hopefully we can find some way of just getting around this issue if it does start to get noisy on certain nanos. It's weird why it doesn't affect those nanos are perfect, Trevor. Why it only affects the appears to be the cheaper ones.
Yeah, it could be a grounding issue with them, and like those other board with the QFN package like that, they have a ground slug underneath them, so they tend to be grounded a little bit better. And so depending on how they did the cheap ones and how they grounded them, they may not be grounded as well, and so that gives you a little bit more noise through them. Okay.
Well, if you've got a couple there, I'll ping you the code after we've finished, and then you can see.
I have a few nanos hanging around. I bought 85 of them at one point, so I have a few left over.
Yeah, I've ordered a couple as well. So the older style, well, the ones that I've got in there, and I'll see how they run. Anyhow, I think we're done, folks. I think we're done. If nobody's got any other questions. No,
thank you.
Excellent.
Thank you, Michael.
Good. Well, hopefully I'll probably see you all next week, intoxicated for a couple of hours in drinks and droids, as we like to do.
Yeah. Thank you for the help. It's always appreciated.
No problem.
Thank you.
And we'll get this posted. Cheers, guys.
Thanks.
Have a good evening. Speak to you soon.
Thanks, guys.
Bye.